Previously, we looked at how to sketch slope fields. In this lesson, we're going to solve separable differential equations. We're going to find both a general equation and a particular solution. So going back to slope fields, I want to talk about this solution curve we sketched at 0, 0 for the equation dy dx equals x plus 1 over y. I talked about in that video the fact that we can actually solve and figure out an equation for the solution curve given that differential equation, which is what we're going to do. So first off, we're going to find a general equation, and then we're going to find a particular solution. So without further ado, let's read this example together. Example number 1 says y prime is equal to x plus 1 over y. Part A says to find a general equation for y, so y equals something, right? And then part B says to find a particular solution at 0, 0, or given that f of 0 equals 0. So again, ultimately what we want to figure out is what is the equation for this curve. But first off, we're going to find a general equation. So a general equation basically represents all of these different slopes. Basically, if we sketch infinitely many solution curves, that general equation covers all of those different solution curves. Pretty crazy idea. So let's go ahead and do that. Step 1, we want to take the y prime and change it to dy dx. Okay, and that's because well, you'll see in a second, but y prime, or any other notation, let's say it's f prime of x, let's go ahead and write that too. Okay, anything that represents the derivative, we want to just convert to dy dx, means the same thing. So let's go ahead and check that off their list and move on to step 2. Okay, step 2 says to separate the y's and dy's from the x's and dx's. So this is why we write it as dy dx, because we want to get our dy's and dx's on the same side. So basically, the way to do this, many times, not all the time, but especially for this example, you want to cross multiply. So you want to multiply y times dy, and you want to multiply x plus 1 times dx. Now you do want to put the y first and the dy's next, and you always want to put the dy's and the dx's to the right. So first of all, when I cross multiply this, I'm going to have y times dy. Okay, and then next I'm going to cross multiply this way, and again I'm going to put my x plus 1 first and then my dx. So on the right side I'm going to have x plus 1. Now notice I'm multiplying the entire x plus 1 times dx, so I'm going to write it that way. So again, that's step 2. Separate the y's and dy's from the x's and dx's. So in other words, everything that contains a y, both y and dy, needs to be on one side, and everything that contains an x needs to be on the other side. It won't really matter which side you put on which, but I will say that typically what I do is I put my y's and my dy's on the left side, and I put my x's and dx's on the right side. It just end up working out a little bit more smoothly that way. Okay, for the next step, we want to put in the form dy dy equals f of x dx. So basically, I'm going to just rewrite what I just figured out. And explain what that means. Okay, so basically what that means is this right here is my gy. It's a function in terms of y. Okay, and I'll put that in blue parentheses, even though it doesn't really matter. And then over here, this is my f of x. This is my function in terms of x. And then next to those particular expressions, we have the dy and the dx. So again, step 3, make sure you put it in this form, dy dy equals f of x dx. It's going to make your integration a lot easier, which leads us to the next step. Now, by the way, why are we doing all this? We're trying to get y by itself. By doing this, okay, let me move this, please. Okay, there we go. By doing this, when we integrate, we can see that it's going to be easier to get y by itself because all the x's over here, the y's are over here. So once we integrate, then we'll just get y by itself, and that way we can find a general equation for y, which is exactly what part A asks us to do. That does lead to step 4, integrate both sides. So we're going to be integrating y dy on the left. Now you can do it at the same time. It doesn't matter. It really doesn't matter at all. But notice that if you do one thing to one side, you have to do the same thing to the other. So integrate the left, And I'm going to put my integral sign on the right, and then we'll go from there. And why are we able to do that? I just totally messed that up. Why are we able to do this? Because the integral, if two things are equal, then their integrals are equal, okay? So let's integrate the left. What is the integral of y? Well, using the reverse power rule, recall that the exponent there is 1, and I made that a little bit too big there. Okay, so the reverse power rule would say that if I add 1 to 1, it's 2. So I'm going to end up with 1/2 y squared. Okay, the dy goes away because I integrated it. Now, on the right-hand side, be very careful about this, and I am going to make a note. What is the integral of x plus 1? Well, the same thing as on the left. Integral of x is just 1/2 x squared. Integral of 1 is x, so it's going to be plus x. And then one more thing you cannot forget. On the x side, okay, so just on the x side, you're going to put your plus c. Now, I can't really explain that right now, other than the fact that your plus c only needs to go on one side, not both sides. So I put my plus c on the right side. Always make sure to do that. Always put your plus c on the side with the x. Now, why is there a plus c? Because we took the antiderivative. Now, again, you don't have to do it on the left. You basically end up with 2 plus c's. You only got one constant of integration. So like I said again, put the plus c on the side with the x. Okay, the next step 5 is to get y by itself. And again, we're doing that because the question asks to find a general equation for y given this differential equation. Remember, a differential equation involves a derivative, dy dx, y prime, whatever, and an equal sign. So now we're going to get y by itself. So what we do now to get y by itself, easiest thing to do is multiply the entire equation, both the left and right, by 2. And the reason we do that is because we're going to get y by itself, right? So that's going to leave us on the left, the 2 and the 1/2 will cancel with just y squared. On the right, the 2 will cancel this 1/2 right here, and you're just left with x squared. But don't forget to distribute that 2 to all of the terms. So it's going to be x squared plus 2x plus c. And then next what you're going to do is to take the square root. Now when you take the square root, don't forget plus or minus. So you get y equals plus or minus the square root of x squared plus 2x plus c. Whoops, I forgot my 2c. I'm not going to forget it this time. So that should be right there. Okay, so we get y equals plus or minus the square root of x squared plus 2x plus c. And that completes this 5th step, which was to get y by itself. So y is by itself now. The question now is, are we done? Well, actually we are for part A. We have found a general equation for y. And again, I want to go back to the graph and talk about what this means, this particular equation. This is a general solution for that slope field that we did in the previous lesson. So what this equation actually represents, notice the plus 2c here. Actually, there is one more step. I did forget. Okay, notice that c is a constant. Okay, so 2 times c would still be what? It would still be constant, right? So the next step is convert any arbitrary constants to just plus c. So instead of just plus 2c, I'm just going to change that to plus c. So for our final equation, we have y equals plus or minus the square root of x squared plus 2x plus c. I'm going to put the plus c in red. I just like to do that. So, even if this was like a plus c squared or something, it doesn't matter what you do to a constant, it's going to remain a constant. So an arbitrary constant basically means, 2c is the same as just c. So just change it to c, and you're going to see why that works out much better when you find a particular solution. So what this equation gives us, I'm going to go ahead and just circle this. This is our general solution, so it answers part A. What this actually gives us is, depending on how you change c, you're going to have different curves on your slope field. So going back to our slope field, there's a lot of different curves that could work for this, and I even created a more advanced slopes field that has more slopes on it, but this is just from -1 to 1. So another possible solution curve on here, let's see, might look something like this. And that would be for a different C value, okay? So this solution curve is not the same as this solution curve. What this general equation gives us is all the possibilities for all those curves depending on how you change C. So if you adjust C a little bit, it will change from something like this to something like this. And that's why sometimes people have a hard time with slope fields, because there's so many different possibilities. And again, that's what this C value does. So we've answered part A, and now we are going to go to part B. We're going to do it in the same example. So part B says find a particular solution given that f of 0 equals 0. So now what we want to do is find an actual equation for this blue line. In order to do that, we just need to solve for C. So let's go back to where we ended up with, where we left off with. We want to solve for C. Now it's set at 0, 0, so we can plug in 0 for x and 0 for y and solve for C, which is exactly what we're going to do. Again, we want to find a particular solution at the point 0, 0. We want to find an equation for this line. So all we have to do is replace both y and x with 0, or whatever they particularly gave us. So there's that. Now I'm going to replace x with 0 as well and solve for C. So real quickly, we get 0 is equal to plus or minus the square root. Now everything in the middle is going to turn to 0 except for the C. 0 equals the square root of plus or minus 0 equals plus or minus the square root of C, and you can quickly see that we get C is just going to be equal to 0. Okay, so now that we've done that, and it's not usually going to be that easy, it is for this particular case. Now that we've figured out C is equal to 0, we can just replace that in our equation, which leads us to the last step. Write the equation for the particular solution. So we're going to replace C with 0 and then just simplify that. So our final answer is y equals plus or minus the square root of x squared plus 2x. Okay, and this gives us, I'm going to rewrite that too, I don't like the way it looks. This gives us an equation for that line. Okay, this right here, y equals plus or minus the square root of x squared plus 2x, is the equation for this curve. Okay, and it's because it's at 0, 0. That's the particular point that we were focused on, and this is the curve that passes through it, which is y equals plus or minus the square root of x squared plus 2x. So that's it for this first example. We found both a general equation and a particular solution at 0, 0. If you have any other questions about this or this differential equation, let me know.